By now, you should have a basic idea of what linear in mathematics means, a way of connecting the relationship between two variables, where the relationship in question may be represented by a straight line. Therefore, the linear equations we have been discussing in the previous section of Chapter 3 help us solve linear problems. At the beginning of Section 3.2, this graph is given as an example representing a relationship between two variables, in this case bags and price. Let's use this example to explain what a model is. In mathematics, a model is a reproduction or replica that is capable of projecting on what we already know. In other words, mathematical models use historical data to predict different make-believe outcomes to help us make decisions. In this section, only linear models will be discussed. Because it helps us in predicting how much any number of bags would cost, this graph is a linear model. Using what we already know, the slope of the line is m equals 5/2, and the y-intercept is 0. The equation of the line is y equals 5/2x. We can now compute the price of any number of bags by the use of the linear model represented by the equation. X represents the number of bags and y the price. Or we can change the variable x and call it b for bags, and y becomes p for price, to make it p equals 5/2b. For example, if b is 150, then p is 5 times 150 divided by 2, or $375. Let's do another example. To move, Pat needs to rent a truck for a few hours. Build a linear model to predict her cost using the following conditions. It costs $40 per day and 50 cents per mile to rent the truck she wants. We begin with the condition that Pat must pay $40 for just starting the truck. That's 0 miles. Therefore, the line for this model starts at 40. From 40, the line climbs at the rate of 50 cents per mile, or $50 per 100 miles. The graph shows this. The slope, m, is 0.5, or 50/100, or 1/2, and the y-intercept is 40. The equation is cost equals 0.5m plus 40, or y equals 0.5x plus 40. If she drives, for example, 70 miles, the cost is y equals 0.5 times 70 miles plus 40. The cost for 1 day equals $75. Another example. Ernestine wants to start a business making shirts. The machinery and other equipment to do the manufacturing of the shirts cost $30,000. She computed the material and labor cost of making one shirt, and she arrived at the figure of $12. Write the equation that would describe Ernestine's linear model. Before the first shirt is made, she pays $30,000. Thus, the first shirt will cost $30,012. The second shirt will cost $30,024, and so on. Thus, the slope of the line is the vertical change, y equals 12, over the horizontal change, x equals 1. So m equals 12/1, or 12, and the y-intercept, that's when x equals 0, is 30,000. Ernestine's linear model is y equals 12x plus 30,000. For example, if she makes 5,580 shirts, it will cost her y equals 12 times 5,580 plus 30,000, or $96,960.